Okay, so y'all should have been doing your warm-up. So when we factor on top, I get x plus 2 and x plus 3. When I factor on bottom, this is a difference of squares, x plus 2, x minus 2. After you factor, you should try to identify your whole or wholes. So if I look at my factored form, I do have x plus 2 I see on top and on bottom. So the 0, if x plus 2 is the factor, the 0 is negative 2. As soon as you take that step, from here forward, you should consider the function no longer that original function. But let's change. So when I plugged in 0 here, I got 3 over negative 2 is negative 3/2. Okay, so I'm about to attempt to graph on the iPad for the first time, so let's see how this goes. All right, so I would like to graph the vertical asymptote and the horizontal, and I'm going to do that first. So x equals 2. I'm going to make that thicker. X equals 2 is the vertical line going through 2. This is my vertical asymptote. Y equals 1. It's right here. I like to label. I think labeling is helpful. So my VA is x equals 2. My HA was y equals 1. In addition to the asymptotes, I also know some points, so I'm going to graph those points. Remember the word whole, you need to be drawing an open circle there. So at negative 2, negative 1/4, that's negative 2 and down just a tiny bit. So that is a whole. I'm trying to go down a little bit. I know that's hard to see on this, but now I'm going to plot the point negative 3, 0. So that's right here. And lastly, I'm going to plot the point 0, negative 3/2. Negative 3/2 is negative 1.5. So that's right here. And you're not going to get any more clear than this picture. Hopefully you can see how you would have to connect this. If you connect these 3 points, you're going down. That's the only thing that could possibly happen. And so you would hug that horizontal asymptote as you end that graph, so to say. So what you have is this part of your function. We need to come over here now. So this is when you use the tangent and together rules. This arrow you would expect to be met with an upward arrow. The only exception to that is if your vertical asymptote came from a double root. So if we go back to how I got x equals 2, was that a double root? No, so therefore a down will be met with an up. So I have an upward here. So your domain, you typically say is everywhere. But we are going to have some exceptions. If I am looking at my domain left, I do have this arrow, so that's all good. But as I move to the right, I have to skip that hole. And then I'm going to keep going. Then I got to skip the vertical asymptote, and then I will go on some more. So I start at negative infinity. Then I get to the hole at negative 2. I want to do the space between that hole and the vertical asymptote, and then everything after that vertical asymptote. Any questions? Okay, so what we're doing today is going to be slant asymptotes. So I'm going to read this definition of slant asymptotes. When the degree of the numerator is greater than the degree of the denominator, the graph will have a slanted asymptote. To find its equation, you must divide the numerator by the denominator by cancellation and usually using long division. So what we're going to do today, we've split slant asymptotes between 2 days. Today we're going to do the, so to say, easier version where you're not going to actually have to divide, but you're going to end up just canceling instead. I do want you to notice that when I say you're just canceling, you know that you're still dividing, right? When you cancel something, you're dividing. I mean, I can do a very easy example to show you. If I ask you what is 8 divided by 2, you could all tell me that's 4. But if I did this in a more complicated way that you would never do anymore, you could say, well, 8 over 2, I know that that's 4, and I can prove it to you because 8 is 4 times 2. And if you have over 2, this 2 over 2 is what cancels to get you 4. So that's basically what we're doing today. Is we're going to take something that's bigger on top, find its factors, hope that they cancel with something on bottom to get the remaining answer. And in this case, our remaining answer is going to be the slant asymptote. One more thing before let's do, in the first half of this, we're just practicing what it is that we're doing. So in example 1A, they've even factored for you, but we know that if it wasn't factored, we would certainly factor to start with. But it is factored, so we're just going to start our process. And I'm not changing anything. Everything that we've done up until now, we're going to continue to do, except when you get that case of high over low, slant we go, we're actually going to find that slant equation rather than just saying it's slanted, okay? So how do we start this? What do you do as soon as you factor? You look for your holes. Do you have a hole here? How do you know if you have a hole? Yeah, the factor x minus 1 you see on top and bottom. So what does that tell you the x value of the hole is? Positive 1. How am I going to find that corresponding y value? Okay, but what function am I going to use now instead? X plus 2. So your new function, you've kind of like crossed these off. You don't need them anymore. So x plus 2, you have nothing on bottom. If you would prefer to write over 1, that's fine, but writing over 1 is not really that important, so I'm not going to. But if it helps you to write over 1, go for it. Okay, so what I'm going to do is I need the corresponding y value right here. So using this x of 1, I'm going to plug it in. 1 add 2 is 3. And so that's the corresponding y value. So this function would have a hole, an open circle at 1, 3. Okay, our vertical asymptote. This is found by the factors on the bottom. But using our new function, do you have a factor on the bottom? Is 1 really a factor? A factor are things with x's. So no, we don't have a vertical asymptote. You don't have a factor on bottom. You don't have a vertical asymptote. I really would recommend you writing none. I'm scared if you write 0 that you're going to try to graph 0 somehow. So write the word no or none or something like that. In my experience, writing 0 is not good. Okay, our horizontal slash slant asymptote. So the process that we would go through using, again, the new function. There's absolutely no need to go back to the first function. So using the new function, I have x to the 1 over, how many x's are on bottom? None. So I do have high degree on top, no degree on bottom. So that's high over low, slant we go. And so today we're going to talk about what is that slant. So in the definition it said to find its equation you must divide the numerator by the denominator by cancellation. So have we fully divided the numerator by the denominator? Can you do any more division? No. So this is the end result. Therefore this is your slant asymptote. So we're going to write y equals x plus 2. And so we all know how to graph y equals x plus 2. That would have a y-intercept of 2. Interesting, I'm saying y-intercept. But we'd have a y-intercept of 2 and a slope of 1 over 1, up 1 over 1. Okay, x-intercept.
The slant asymptote is really just like how you graph a linear function.
Yes, it is. Yes. Your x-intercept is your root on top So x plus 2 gives you the root of negative 2. What's the corresponding y value?
0.
Absolutely. And your y-intercept is always found by plugging in 0. So 0 plus 2 is 2. Does that kind of make sense based on what I said earlier?
Is that like a coincidence or is it?
It is not a coincidence. We're going to talk about why when we get to the first real example. Okay, let's do B. So in B, as you can see, you're not factored. So they are asking you to go through that first process of factoring. If you look at your numerator, this is a 1, 2, 3, 4-term polynomial. There's no GCF. So the only way you can factor this is by automatically starting with grouping. So I will group and group. So what comes out of my first group is x squared. X plus 4 is left. What comes out of my second group is minus 1. X plus 4 is left. So if I write my factored equation, I have x squared minus 1 and x plus 4. But is that fully factored? No. What is the fully factored answer? Good. Difference of squares here makes it x plus 1, x minus 1, and x plus 4. So x plus 1, x minus 1, x plus 4. And on bottom, it's that same thing, x plus 1 and x minus 1.
So wait,
Oops, I don't know why I wrote 2.
holes?
Say it again, Tara.
So you have 2 holes?
Yes, we will have 2 holes. If you look, you have x plus 1 on top and bottom, so that gives you a hole at negative 1, comma, something, I don't know. And x minus 1 top and bottom gives me 1 comma something. So how am I going to figure out these somethings? What is the function I'm going to consider to find out those somethings? Just x plus 4. That's all I have left. So it's to find these corresponding y values is as simple as plugging in negative 1 for x. Negative 1 plus 4 is 3. And positive 1 plus 4 is 5. So we haven't seen something with 2 holes before, but as you can see, it really doesn't change anything. It's just you're going to have 2 circles on your graph instead of just 1. I actually like having more points because the more points that you have gives you a better idea of what the graph should look like. So this is actually a good thing. All right, let's go on though. What is my vertical asymptote? I'm sorry? None, because if y'all want to write over 1, it might be easier in the beginning. So your denominator doesn't have a factor, so therefore you're not going to have a vertical asymptote. That's going to change tomorrow, but today you should be writing none on these examples. Okay, our slant asymptote, it is slant because it's high over low, slant will go. We've already divided. There's nothing left to divide. So x plus 4 is the answer to our division. Y equals x plus 4. My x-intercept is found by the factor on top. So x plus 4, set it to 0 is negative 4, comma 0, and 0, comma 4. Any questions so far? I know we haven't actually graphed it, so right now you're just being a robot doing things you know to do. Okay. So if I have an XY graph and I just asked you to draw a slanted function. That's a slanted function. What kind of equation would you be expecting for this slanted function? Linear. So for all of these, you are expecting a linear y equals mx plus b. And that's how we're going to graph it, is we'll know that m is the slope and the b is the y-intercept. So that's kind of where we're headed in this. Okay?
Is that like when the bottom cancels out?
You still go through the same process. By the way, at this point, I'd like to just talk about the test that you're going to have next Wednesday. It is a test. We don't have a quiz over this. The test is going to be set up exactly how you see. So the more homework that y'all are doing, the better it is for you. I'm not going to change the format in any way. But the downside to that is that occasionally you won't have a whole, but I'll still ask you for a whole. So you'll have to write none. Just like on the VAs, if you don't have a VA, you just write none. So I don't want you on the test to get worried and say, well, you're asking me for this, but it's not even part of it. Just know that I want to keep this little format the same, and so that's why I'm going to do it like that, so you know the order that you go each and every time, okay? All right. So let's do this example. We're going to start off the same way. Again, this formula is given to us in factored form. It kind of saves us a first step, which is good. As soon as I look at that factored form, I do notice that I have a whole at -1. So -1 comma what is the question? So f of x is now going to be equal to x minus 4, and I guess let's put it over 1. It's not a bad habit. So to find the y value, I would plug in -1 here, subtract the 4, and I get -5. Once again, my vertical asymptotes denominator is none. Once again, my slant asymptote, it is under the case of high over low. Slant will go. We've already divided as much as we can, so x minus 4, y equals x minus 4 is the slant asymptote. How do you find your x-intercept? It's the root on top, so x minus 4 equals 0, so 4 comma 0. The y-intercept is found by plugging in 0, and you get -4. All right, what I'm about to claim to you is that these two functions will look the exact same, and it's because they do this perfect cancellation. If they don't do that perfect cancellation, that is not going to be the case. But when they do this perfect cancellation, leaving you with nothing in the denominator, this turns into just a line, just a line. And so what I'd like to do is show you why in a little bit more conclusive way. I'm going to start with my slant asymptote. So x minus 4, -4, 1, 2, 3, 4 is my y-intercept. I'm going to go up 1 over 1. And to the best of my ability, there we go. So that's my slant asymptote at x minus 4. I don't have a vertical asymptote to graph, so I'll skip that. I'm going to graph the whole at -1, -5. 1, 2, 3, 4, 5. That's my whole. 4 comma 0 and -4 comma 0. And so as you can see, if you tried to plot those points or connect those points, yeah, you don't have any choice but to go exactly on that line. So in this case, to highlight your slant asymptote isn't really that helpful. I still like to do it. Keeps my work consistent. I always know what I'm doing. So the only restriction on my domain is going to be this whole. Okay? So that's -∞, -1, union -1 to infinity. Yeah, today, and honestly, if you have a good understanding of today, tomorrow's not that bad either. You just have to, we have to take one extra step. So today it's important to understand the concept of the slant asymptote, the fact that you had to divide to get there. Even though we didn't really divide, we just canceled, but it is still dividing. And that's how we got the slant asymptote. That's what you need to take away from today. In addition, we do have this last this is the last like brand new concept, and it's not a new concept. It's the idea of x approaching. So they tried, I don't like really the way that they say this, so I'm going to write my own thing. So if I said as x goes to, that's an arrow, x is going to a number from the little minus. That's telling you the direction. It's saying don't go exactly to that number, go just a tiny bit less than. Negative means less than. So that means you look at the number but barely. If you're going less, are you going to look to the left or are you going to look to the right?
This is null number.
To the left.
Let's see. Okay, I did not see that.
So you're going to look at the number barely to the left. I'm not saying like a full number, but just look at that number and then look barely to the left of it. As opposed to x approaching a number from the positive direction would say look barely to the right. That says look barely to the right. That's pretty rough handwriting, but. Okay, so let's do this example. I like these problems because they're a really good introduction into future math classes for you. Because they talk about approaching, and that's what future math classes are going to do a lot. So
This look more like calculus.
this is very much like calculus. Okay, so what we're going to do is we are going to use the graph to the right to determine.
Please pardon this interruption. The JV baseball team will...
I am going to show you. Oh, I forgot to record that too. Dang it. Kind of watch and grasp what I'm saying. So, what I'm going to show you is that if, whoa, that's not going to work. If I told you the function f of x equals x minus 4, x plus 1 over x plus 1, and I'm comparing it to the function just x minus 4. And so the best way for me to do a comparison is to do an XY chart. So let's say we start off with -5. -5. I'm going to do it in both places. So if I plug in a -5, this is -5 minus 4 is -9. -5 plus 1 is -4. -5 plus 1 is -4. What do you notice about what you have on top and bottom? This is cancels, and it just turns to -9. So when you plug in -5 here, subtract 4, you are just going to get that -9. It doesn't matter what points you put in here. It's always going to cancel so that this would cancel with this, leaving you with just what you got from x minus 4. The only exception to that, what is the only exception to that going to be? The whole, -1. If I plug in -1 here, I get -5 over 0 over 0. And that's what causes this to be undefined. But when I plug in -1 here, I do get -5. Which, by the way, look at your piece of paper. What did we claim the whole is going to exist at? -1, -5. So the only difference between these two things, they are both going to be, they are both going to be a line at x minus 4, something like that, but one of them is going to have a hole and one of them would not. Does that make sense? Okay.